So let's say I have one pipe, I have one, let's say one pot, okay, and water is here, and I have one pipe passing through this, okay. So T 100 degrees centigrade and T1, T2 equals, let's say temperature will be going down, let's say 20 degrees centigrade water, T2 maybe 30 degree, okay. Exit fluid temperature. So what is the temperature difference at the beginning here at this location? Temperature difference will be like 100 minus 30, yes, 100 minus 20, okay. And here at point 2, temperature difference will be 30 minus 20, right. So this will be GTD, this will be LTD, okay, lower temperature difference and higher temperature difference. No, here something error is there. So because of pipe, water temperature will be going up. So at inlet water temperature may be higher, at exit water temperature will be lower, or maybe if you are using one bath only, so all time water temperature will be maintained. So only the piping temperature changing. So I am assuming only piping temperature changing. Okay, I am using the water temperature continuously, it is 20 degree. Okay. So in that case, Tm equals GTD minus LTD divided by log of GTD greater temperature difference by lower temperature difference. Okay. So what about temperature? Constant, we are assuming. So normally in surface separator system it will be like 180 degree Fahrenheit, they are assuming, okay, approximate thumb rule you can say. VO overall okay, VO overall film coefficient, COE film coefficient or heat transfer coefficient, because temperature is changing from inlet to outlet. So the H value also or V value also will be changing from inlet to outlet actually, but they are saying overall average film coefficient temperature. Okay. For low pressure, about 35 degree API, they have given a formula, API oil. The formula is like this: Q equals QT 6.25 plus 8.33 X del T. Okay. So QT is the total liquid flow rate, total liquid flow rate. Okay, total liquid flow rate unit will be BPD, barrel per day, BP not BPD. Okay, X, one term is used here. X is decimal water, DECIMAL water, decimal water constant. Okay, now how much fraction of water is there in the fluid? So that percentage. We'll solve one problem, so that time we'll understand how to calculate X. Okay. And del T, the temperature difference between inlet and outlet. Temperature difference between inlet and outlet. Okay. So and degree Fahrenheit. Okay. Overall film heat transfer coefficient. Okay. You want to go to previous? Okay, overall film or heat transfer coefficient, overall film or HT heat transfer coefficient, it will be like VO mixture, VO oil plus VO water minus VO oil here, and this is based on clean tube. Okay, so there will be 1x. This is based on clean tube or no allowance for fouling factor, or no allowance for okay. So yeah, these are giving the book, so you can see verify also this equation if something goes wrong. Okay, and fouling factor I'll explain. Done this one. Okay, so fouling factor. I said scaling sometime back, right? So you have one pipe. When fluid is flowing through the pipe, and if you have salt means like sodium chloride or any other salt, you are drinking water, you are drinking. So ppm, they will be specifying, the municipal authority or your Bisleri or other companies, ppm parts per. So how much salt is there actually, salt content, minerals or other things, actually they will be those will be there in the form of salt. Okay, so those salt, once you are evaporating thing, so water will get evaporated, but salt will not get evaporated. Okay, so they will be depositing at the bottom or inside pipe. If you have contaminant, that also will get deposited on the walls. Okay, those will create foam or fouling. Okay, so what is the effect? I already explained that normally, let's say you have copper pipe. Okay, copper pipe heat transfer rate is very high. Okay, convective heat transfer rate, conduction heat transfer rate. Okay, now you have this other material, this salt deposition or contaminant deposition, their heat transfer rate will be lower. Okay, their heat, so like scale or fouling, high HT coefficient. Okay, heat transfer coefficient or conduction, right? And fouling, if is there, then low heat transfer coefficient, low heat transfer, because the heat transfer low, so whatever heat is getting generated, that will not get transferred completely. Okay, so your system efficiency will be reduced. And in separator heat treater system, I read some document, they are saying like, because of this low heat transfer coefficient, you design something, heat is not getting transferred, so internal heat accumulation will be higher. When heat is getting accumulated, temperature will be shooting up. Okay, so that will create rupture and failure. Okay, so you have to see whether that scaling is there. So normally in boiler application, steam engine, other cases, they will be giving salt free water. All the minerals and salt they will be removing, they will be putting inside boiler system, so that there will be no deposition. Okay, so normal tap water or river water, ocean water, water you get, so they will be having lots of salts. So that same salt you cannot use for boiler application actually. Okay, because of scaling issues. And boiler normally, these systems normally, whatever water you are boiling, so that same water will be getting circulated. Okay, same water getting circulated, but still there will be some leakage or some other issues, so water volume will get reduced. So you have to give some makeup fluid all time. When you are giving makeup fluid, that makeup fluid should have salt free. Okay, then make it salt free and put it, then things will be okay. If there is some scaling or fouling, then you have to give, when you are doing heat transfer calculation, you have to give certain allowance. So you have, like say 100 BTU heat transfer was there, because of scaling heat transfer rate reduced. So then accordingly you have to give that much of allowance. So presently in this formula, they are not using that fouling factor, because of this fouling or deposition on the surface, heat transfer rate actually reduced, conduction heat transfer rate reduced. So that one they are not considering at this moment. They are assuming this clean water you are using, so no scaling or no fouling. Okay. So fouling or scaling will be very much disastrous in boiler application, or very high pressure they are using. For example, steam turbine system, they will be using several hundred bars pressure. So in that case, very high pressure and fouling is there. So heat transfer rate will be lower, boiler efficiency will be down. Again, because of this uneven heat conduction and issues, there will be overheating and other issues. So we will try to solve one problem. I have one. written or not? Not written. Okay, then we'll write. Your slides are not going in sequence. Okay. Okay, so write down one problem using those formula. We'll try to solve. Okay. Calculate heater size. Heater size. Okay. Heating for heating crude oil in gun barrel. For heating oil plus water in a gun barrel. Okay, so Q oil flow rate 2500 they have assumed BPD. Q water flow rate assumed 1400 BPD. Inlet temperature 60 degree Fahrenheit. T outlet temperature 100 degree Fahrenheit. Okay, so required coil size, so there will be one piping or coil, so that required coil size 3-inch iron, cast iron. Required coil size 3-inch cast iron. Okay, so this will be used when we will be calculating final sizing. So initially heat transfer how much there, so that one I have to calculate. Okay, oil API, oil gravity 35 degree API, and assume VO oil, that film coefficient for oil 35.7 BTU per hour feet square degree Fahrenheit. Okay, so this one like this. V water 117.5 same unit. Okay, so this data is given, and VO and oil and water actually they found from one table. So instead of giving table, I am giving directly values. Okay, so in problem if I give table, then you have to find actually better. I will try to give a table. So I will give data VO VW, based on that you can calculate. Okay. Solution. So Q equals QT. You can remember the formula 35 degree API, the formula 6.25 plus 8.33 x delta. Okay. Now total flow rate QT, total flow rate is given 2500 plus 1400 equals 3900 barrel per day, BPD. Okay, total flow rate, and temperature difference TO minus TI equals 40 degree Fahrenheit. 100 minus 60 equals 40 degree Fahrenheit. So Q formula you can remember, QT 6.25 plus 8.33 x into del T. Okay, so this is giving 3900, already we have obtained, right? 39 QT already 3900, 6.25 plus 8.33 x. X we are getting like this, x equals 1400 divided by 3900, fraction of water. Okay, so it is giving 0.36, 0 point, and T value we got already 440. Okay, so this is giving 1442813 BTU per hour. So how much heat transfer required we are getting per hour. Okay, so now heat transfer coefficient equation, coefficient coefficient equation, VO max okay, VO max equals VO oil plus VO water plus VO oil X. Okay, so oil flow rate QO equals 2500 divided by 24 equals 104.2 barrel per hour. Q water equals 1424 because barrel per day, so you can convert it into hour. Okay, so equals 1400 divided by 24. Sorry, is coming 58.4 barrel per hour. So now LMTD TM equals 180 minus 60. I'll do GTD. GTD equals 180 minus 60. Why 60 coming? Okay, 60 inlet temperature. So it is 120. 180 means water bath temperature they are assuming, fixed temperature 180 degree. Okay, 120 and LTD 180 minus 100. So it is coming 80. Okay, degree Fahrenheit. Now TM is coming 40 divided by log of 120 divided by 80. So finally it is coming 98.7 degree Fahrenheit. So coil area Q by VOTM. So 1442813, the flow heat transfer rate divided by 117.5 into 98.7. So this value came actually, if we put all the values, it will come 117.5. Okay, so this is giving 124.4 feet square. Okay, now you got your heat transfer Q rate 1442813. Okay, now you see the table. I have one table I copied from one book, Leon. So this is becoming this range. Okay, the rating is given. So whatever you calculated, it is nearby this rating. So nearby this rating is size, you got this one, diameter and length. Okay, this will be your separator system size. So standard direction for indirect heater for cast iron coil, already given cast iron coil data, right? So for cast iron coil, this one your size. Okay, thank you very much for today lecture. Tomorrow we'll start new topic. Thank you.